In this lab, we'll have a look at equal cost multipath with a lab demo. Now to start off, I'll use the same lab again where it's unequal cost paths. So we've got the topology with R4 going down to R1, and the 10.0.1.0/24 network is behind R1. And R4 can get there either via R3 or via R5. And what I've done in the lab already, I've configured all the IP addresses and I've configured RIP on all the routers as well. So to get to the routes behind R1, R4 is going to go via R5 because it's got a lower hop count. It's only 2 hops via R5, it's 3 hops via R3. So let's have a look at that in the lab. And if I do a show IP route on R1, actually that's going to show my routes going back to R4. Let's have a look at R4 going to R1. So I'll do a show IP route there. And I can see my route for 10.0.1 is going to go via 10.1.3.2, which is on R5. And I've only got one route to get to 10.0.1 because it's the best path. It's better than the route going through R3. Okay, so that's what happens when we've got this lab topology with unequal cost paths. What happens if I change the lab topology with equal costs? So what I'm going to do is I'm going to reconfigure the lab. I'm going to put in R6 in here. So that way it's going to be 3 hops, whether we go via R3 or go via R5. Now, at first, I'm going to leave the links on R5 as 10 meg compared to 100 meg fast Ethernet on all of the other links. And you're going to see the difference that makes whether we're using RIP or OSPF. So I'll go and reconfigure the lab now. I'll see you back here in a second. Okay, I'm back again, and if we have a look at the old config, you'll see that R5 was directly attached to R1 with its fast 3/0 interface. What I've done is I've put an R6 in there, so fast 3/0 on R5 is now connected to R6, and I've changed the subnet. I've made that a 10.1.4 subnet. And R6, its fast Ethernet 3/0 interface has now got the IP address 10.0.3.2 that used to be on R5. I still have the links on R5 as 10 megabits per second. The links everywhere else are 100 meg. So let's just check the differences that I made in the configuration. So if we have a look at R5, you see I've just changed the IP address on that link to R6. I've put it in the subnet 10.1.4. And on R6, I have configured its IP address on fast 0/0 going back to R5, and I've configured RIP on there. I can actually see I forgot to do something. I also need to go interface fast 3/0, which is connected to R1, and it's going to get IP address 10.0.3.2 with a /24. That's the IP address it used to be on R5, and do a no shut on here. Okay, let's just check that RIP is running everywhere. So I'll do a show IP route on R6. Might take a minute for RIP to run on here. Okay, there we go. So there's our RIP routes showing up. So now if we go and have a look on R4, before R4 just had that one route to the 10.0.1 network behind R1, also for the 10.0.2 network behind R1 as well. But I can see it there, so 10.0.1 and 10.0.2, there's just one route which is going out the fast Ethernet 2/0 interface because it was the best route going down that bottom route via R5. But because I've made those changes now, both the top and the bottom path are equal cost. They've both got the same hop count, which is going to be 3 hops. So if I do a show IP route now, the routing protocol should have converged by now. And it hasn't yet. I can see that I've still got one route. Okay, you know what I'll do to speed things up is I will do a no router RIP to disable RIP, and then I'll enable it again. So I'll say router RIP, and it was for network 10.0.0.0. And let's see if it speeded things up a bit. I'll do a show IP route, and there's the difference now. I can see that for the 10.0.1 network, it's now going to go via two paths. 10.1.3.2, which is on R5, and 10.1.1.2, which is on R3. So it's going to load balance via both of those routers. It's also going to do it for the 10.0.2 network, which is also behind R1 on the right. Okay, so that's just configured equal cost multipath for RIP. Let's see what happens if we enable OSPF on here now. So I'll go to my text file again, and I'll paste in a basic config for OSPF. I'll do that on all of my routers. Actually, let me just put in a config T in front of here to save me typing that every time. Okay, so I'll copy this and paste that in on every router. So that's R1, R2, R3, R4, R5, and R6. And let's see if it's converged yet or not. So back on R4, I'll do a show IP route, and I should see the RIP routes being replaced with OSPF routes, and just come up now on R4. So again, you see it does take the routing protocol a little bit of time to converge, and there's the other neighbor. So if I do a show IP route on here now, I can see that my RIP routes have been replaced with OSPF routes. And you saw for RIP, I had two equal cost paths going through both R3 and R5. But OSPF is just put one route into the routing table for the 10.0.1 and the 10.0.2 networks. So why is that happening? Well, if I go back to the topology diagram, you'll see that the links on either side of R5 are 10 meg. The links along the top path are 100 meg. So these were equal cost when it was with RIP, because it just looks at hop count, but OSPF takes bandwidth into account. So the top path is the better path here. That's why it's the one that was installed into the routing table. So if I want to get equal cost multipath here, what I can do is go on to R5 and make those links 100 megabits per second as well. So let's just check what interfaces they were on. I'll do a show IP interface brief. They're on fast 2.0 and 3.0. So I'll go to global configuration, interface fast 2/0. And just to check the correct command, I can do a do show run interface fast 2/0. And I want to do a no, and then in my client here, I can just select the bandwidth, right click, and it will paste it in. So that's going to remove that manually configured bandwidth, and it's going to set it back to the default bandwidth of 100 megabits per second. So I need to do that on fast 2/0 and also on interface fast 3/0. And I'll put the command in there as well. And I need to do that on the other sides of the link as well. So I'll go over to R4, do a config T, and it's on interface fast 2/0 on this side. Now let's double check it. So I'll do a do show run, interface fast 2/0. And I can see I've got the lower bandwidth configured there as well. So I'll remove that command to set it back to the default. And also on R6, this is on interface 0.0. So I'll do a do show run, interface fast 0/0. And I can see the lower bandwidth is configured there as well. I'll remove it there too. The wrong prompt there, so I need to go interface fast 0/0, and I'll try that again. And there we go, we're done. Okay, So again, we might need to give this a little bit of time to converge. But if I go into R4 now, so before it just had that one route going to the routes behind R1. If we try a show IP route now, yeah, we can see it's converged already. So now, because it's two equal cost paths, to get to 10.0.1.0, it can go via 10.1.3.2, which is on R5, or 10.1.1.2, which is on R3. And also for 10.0.2.0, also behind R1, it's going to load balance the traffic over those two different paths as well. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.